Rocket Lab's journey, analyzing 20 milestones from 2013 to 2023 and their impact on future space ventures.
Introduction.
Rocket Lab, founded in 2006 by Peter Beck in New Zealand, has established itself as a key player in the aerospace industry, particularly in the small satellite launch market. This report examines 20 significant milestones from 2013 to 2023, emphasizing their innovations, market impact, and potential implications for future space ventures.
Timeline of key milestones. 1. 2013, relocation to the U.S.
Rocket Lab moved its headquarters to Huntington Beach, California to access the American aerospace market and attract U.S. investors, including Khosla Ventures.
2. 2017, first test flight of Electron.
The Electron rocket made its maiden flight, reaching space but failing to achieve orbit.
This marked the beginning of Rocket Lab's journey into orbital launches. 3. 2018, successful launch.
Rocket Lab celebrated its first successful launch of the Electron rocket, deploying 3 CubeSats,
and secured its first government contract with NASA.
4. 2019, development of reusable technology.
The company began developing technology for the recovery of the Electron rocket's first stage, signaling a move towards reusability. 5. 2020, first booster recovery attempt.
Rocket Lab attempted its first recovery of the Electron booster, choosing a water landing over mid-air capture.
6. 2021, public listing via SPAC.
Rocket Lab went public through a SPAC merger, raising significant funds for development, particularly for the Neutron rocket aimed at larger payloads.
7. 2022, successful booster capture.
A major achievement occurred when Rocket Lab successfully captured an Electron booster with a helicopter, enhancing its reusability capabilities.
8. 2023, record launches.
The Electron rocket completed a record 10 launches in 2023, even while facing a mission failure.
Plans for the Neutron rocket's launch in 2025 were also announced. 9. 2024, major U.S. Space Force contract.
Rocket Lab secured a $515 million contract with the U.S. Space Force,
its largest to date, cementing its position in the defense sector. Common themes and key points. Cost reduction and accessibility.
Rocket Lab's Electron rocket has made small satellite launches significantly more affordable, with prices under $5 million per launch. This accessibility is crucial as satellite technology becomes increasingly compact and cost-effective.
Innovation in reusability. Rocket Lab's focus on reusability reflects a broader trend in the aerospace industry, similar to SpaceX's initiatives.
The development of reusable rockets aims to reduce costs and promote sustainability in space operations.
Public and private partnerships.
Strong collaborations with NASA and the U.S. military have enabled Rocket Lab to participate in various missions,
including lunar exploration.
These partnerships enhance the company's credibility and market position.
Future implications.
Rocket Lab's trajectory from 2013 to 2023 indicates a significant shift towards the miniaturization of satellite technology and democratization of access to space. Their advancements in reusability and government partnerships position them well for future endeavors, including large-scale satellite deployments and interplanetary missions such as the Venus Lifefinder, slated for 2025. As Rocket Lab continues to innovate, its potential impact on the space industry could parallel the transformative effects seen in other sectors such as automotive with Ford. The company's efforts to reduce costs and enhance accessibility could pave the way for a more vibrant and diverse space economy.
Conclusion. Rocket Lab's journey over the past decade illustrates important milestones that have shaped its role in the aerospace industry.
Through its innovative technologies, strategic partnerships, and commitment to reducing launch costs, Rocket Lab is poised to significantly influence future space ventures. Their developments not only enhance current capabilities but also inspire a new generation of space exploration and commercialization. The analysis of Rocket Lab's journey from 2013 to 2023 reveals several counterintuitive insights regarding the evolution and impact of the company on the space industry.
Here are some of the most significant points.
1. Cost reduction versus technological complexity. While the aerospace industry has historically been associated with high costs and complex technologies, Rocket Lab's approach with the Electron rocket challenges this notion. The Electron's affordability, less than $5 million per launch, means that smaller companies can now enter the space market, contradicting the expectation that only large,
well-funded organizations can afford to launch satellites.
2. Increased accessibility leading to market saturation. The democratization of space access through reduced launch costs may lead to market saturation rather than a sustainable increase in demand. As more players enter the market, the risk of overcapacity and price wars could emerge, which is contrary to the expectation that lower costs would lead to a stable increase in satellite launches. 3. Reusability as a double-edged sword. Rocket Lab's focus on reusability mirrors trends established by larger players like SpaceX. However, many expected reusability to be a straightforward path to cost savings. In contrast, Rocket Lab's experiences, such as failed attempts to recover boosters, highlight the technical challenges and risks involved in developing reusable systems, which can lead to increased costs and delays in the short term. For public-private partnerships are not just for large contracts. While many view public-private partnerships as beneficial primarily for large-scale contracts, Rocket Lab's success in securing smaller government contracts like those with NASA demonstrates that these partnerships can also significantly benefit smaller companies. This challenges the assumption that only major players can thrive in such partnerships. 5. Geographical relocation with unexpected benefits. The move of Rocket Lab's headquarters from New Zealand to the US was perceived as a strategy to tap into a larger market. However, this shift also brought unforeseen complications, such as the need to navigate a more complex regulatory environment and competition from established American players, suggesting that growth strategies based purely on market size may not always yield expected benefits. 6. Failure breeds innovation. Initial mission failures, including the Electron rocket's first test flight, were expected to hinder progress. Instead, these failures became a catalyst for innovation, leading to improvements in technology and operational practices. This challenges the traditional view that failure is primarily detrimental and suggests that it can be a crucial component of a learning-oriented approach in high-tech industries. 7. Small scale doesn't mean small impact. Despite being a smaller player compared to giants like SpaceX or Blue Origin, Rocket Lab's continuous innovations and successful missions have had a significant impact on the industry, particularly for small satellite launches. This counters the notion that only large companies can drive substantial changes in an industry. 8. Vertical integration as a risk factor. Rocket Lab's strategy of vertical integration, acquiring companies to control more of its supply chain, was expected to streamline operations. However, it introduces risks such as integration challenges and potential distractions from core competencies, highlighting that growth strategies can have unintended consequences. 9. Funding as a double-edged sword. While significant investments such as those from Khosla Ventures were expected to facilitate growth and innovation, they also come with pressure to deliver returns. This can lead to short-term decision-making that may conflict with long-term strategic goals, indicating that funding isn't always a straightforward advantage. 10. Regulatory environment as a catalyst for change. The evolving regulatory landscape, particularly in the US, was initially seen as a hindrance to rapid growth. However, it has prompted Rocket Lab to innovate in areas such as safety and compliance, illustrating that regulatory challenges can drive companies to improve and adapt. Contrary to the assumption that regulations are solely barriers to growth, These counterintuitive insights from Rocket Lab's milestones between 2013 and 2023 suggest that the aerospace industry is undergoing transformative changes driven by innovative approaches, strategic partnerships, and adaptive learning processes which challenge conventional wisdom about costs, accessibility, and the nature of competition in the space market.
Important content in the report on Rocket Lab's journey 2013 to 2023. 1. Relocation to the U.S. 2013. The decision to relocate its headquarters to the U.S. from New Zealand is significant as it reflects Rocket Lab's strategic intent to access a larger market and gain substantial funding. This move allowed Rocket Lab to establish relationships with key stakeholders in the U.S. aerospace industry, positioning itself to secure government contracts and partnerships, particularly with NASA and the U.S. military. This shift not only impacted its funding but also its operational capacity and market presence. 2. First successful launch and NASA contract 2018. The first successful launch of the Electron rocket marked a critical point for Rocket Lab, validating its technology and opening the door to commercial contracts. Securing its first government contract with NASA demonstrates the trust and confidence that a major space agency has in Rocket Lab's capabilities. This milestone is often overshadowed by the technical achievements but is crucial for establishing credibility and market presence. 3. Development of reusable technology 2019 to 2021. While many may focus on Rocket Lab's successful launches, the development of reusable technology is a pivotal aspect of its long-term strategy. The push towards reusability mirrors industry trends established by SpaceX and is essential for reducing costs and increasing launch frequency. The ability to recover and reuse rocket components significantly changes the economics of space launches, making them more sustainable and financially viable. 4. SPAC merger 2021. The transition to a public company through a SPAC merger is a notable milestone that provided Rocket Lab with increased financial resources. This financial boost was crucial for supporting the development of the Neutron rocket and expanding its operational capabilities. The implications of becoming a publicly traded company are profound, as they allow the company to leverage public markets for future growth and innovation, which is often overlooked in discussions about technological milestones. 5. Helicopter capture of Electron booster 2022. Successfully capturing an Electron booster with a helicopter was a pioneering achievement in rocket reusability. This event not only demonstrates Rocket Lab's engineering prowess but also sets a precedent for future recovery operations. The significance of this milestone lies in its potential to influence the design and operational strategies of future space launch systems, creating a new paradigm for reusability that could inspire other companies. 6. Record number of launches 2023. Achieving a record of 10 launches in a single year despite a mission failure highlights Rocket Lab's resilience and operational capacity. This ability to maintain a robust launch schedule demonstrates the company's operational efficiency and reliability, which are critical for attracting new customers and contracts, especially in a competitive landscape. 7. Expansion into defense sector 2024. Securing a $515 million contract with the U.S. Space Force represents a significant expansion of Rocket Lab's business into the defense sector. This milestone is significant not just for the financial aspect but also for the strategic alignment with national defense interests, enhancing Rocket Lab's reputation and influence within the aerospace industry. 8. Future plans for Neutron rocket and Venus mission 2025. The plans for launching the Neutron rocket and the Venus Lifefinder mission underline Rocket Lab's ambition to scale up its capabilities and engage in more complex missions. The development of Neutron, aimed at larger payloads and potential human-rated missions, reflects a long-term vision that could reshape Rocket Lab's business model and competitive positioning in the aerospace sector. Why these points are significant. These milestones are crucial not only for understanding Rocket Lab's trajectory but also for grasping the broader implications for the aerospace industry.
1. Market accessibility. The affordable launch services provided by Rocket Lab democratize access to space, enabling a wider range of actors, including startups and research institutions, to deploy satellites. This shift could catalyze innovation in satellite technology and applications influencing fields such as telecommunications, Earth observation, and scientific research. 2. Sustainability in space exploration. The emphasis on reusability is vital for making space exploration more sustainable. By reducing costs and waste associated with single-use rockets, Rocket Lab's innovations could lead to more frequent and responsible use of space resources. 3. Strategic partnerships. The relationships forged with government entities signify a trend towards increased collaboration between private aerospace companies and public institutions. This could pave the way for more public-private partnerships, enabling shared knowledge, resources, and funding that can accelerate advancements in space technology. 4. Competitive landscape. Rocket Lab's advancements and strategic decisions illustrate the rapidly evolving competitive landscape of the space industry. As private companies increasingly take on roles traditionally held by government agencies, the dynamics of space exploration and commercialization are changing, with potential implications for regulation, funding, and international collaboration. 5. Technological innovation. The focus on developing advanced rocket technologies, including the neutron and photon systems, reflects a commitment to innovation that could inspire new applications and developments within the aerospace sector. As Rocket Lab continues to push boundaries, its efforts could lead to breakthroughs that benefit not only commercial ventures but also scientific exploration. In summary, while key milestones in Rocket Lab's journey may seem straightforward, their implications extend far beyond the company itself, affecting the entire aerospace ecosystem and setting the stage for future innovations and collaborations in space exploration. For valuable points for in-depth analysis of Rocket Lab's impact on future space ventures. 1. Cost reduction and accessibility in satellite launches. Rocket Lab's development of the Electron rocket has drastically lowered the cost of launching small satellites, with prices dropping to under $5 million per launch. This significant reduction opens up space access to a wider range of companies, universities, and researchers, fostering innovation in satellite technology and applications. The implications of this cost-effective approach could democratize space exploration, allowing smaller entities to participate in satellite deployment and enabling a variety of new services such as improved global internet access, enhanced weather forecasting, and real-time environmental monitoring. Analyzing this trend can provide insights into how competitive pricing structures in the aerospace sector can stimulate growth and innovation. 2. Advancements in reusable rocket technology. Rocket Lab's focus on reusability, particularly with the Electron rocket and its planned Neutron rocket, marks a significant shift in launch vehicle design and operational strategy. The successful recovery of the Electron booster with a helicopter in 2022 exemplifies the company's commitment to sustainability and cost-effectiveness. This reusability model mirrors the practices of industry leaders like SpaceX and suggests a broader trend towards operational efficiencies in space travel. A detailed discussion on the engineering challenges, economic benefits, and environmental implications of such advancements can shed light on the future of launch services and their potential to reshape the aerospace industry. 3. Public and private partnerships driving innovation. Rocket Lab's collaborations with NASA, the U.S. Space Force, and other governmental entities have been pivotal in securing contracts and funding for its initiatives. The company's ability to navigate public-private partnerships successfully showcases the importance of these relationships in advancing space technology and missions. Analyzing the dynamics of such partnerships can reveal best practices for future space ventures, including how emerging companies can leverage government contracts to foster growth and innovation while contributing to national and international space agendas. 4. Strategic expansion into defense and interplanetary missions. The recent $515 million contract with the U.S. Space Force demonstrates Rocket Lab's strategic positioning within the defense sector.
emphasizing the growing intersection between commercial aerospace and national security interests.
Additionally, the company's plans for interplanetary missions such as the Venus Lifefinder set for launch in 2025 highlight its ambition to expand beyond Earth orbit. Discussions on the implications of this dual focus, defense and exploration, can elucidate how commercial entities can play a critical role in government-led space initiatives, ultimately influencing the trajectory of both defense capabilities and scientific exploration in the coming decades. These 4 points provide a comprehensive framework for analyzing Rocket Lab's journey and its broader impact on the future of space ventures, encompassing economic, technological, and strategic dimensions. 1. The Wright brothers' first powered Flight 1903. The Wright brothers Orville and Wilbur achieved the first powered, controlled, and sustained flight on December 17, 1903 in Kitty Hawk, North Carolina. This groundbreaking event marked the beginning of the aviation industry and transformed transportation and travel. Their work in aerodynamics and control systems laid the foundation for modern aircraft, paralleling Rocket Lab's innovations in small satellite launches. 2. Apollo 11 moon landing 1969. NASA's Apollo 11 mission culminated in the first human landing on the moon on July 20, 1969. Astronauts Neil Armstrong and Edwin Buzz Aldrin made history by walking on the lunar surface while Michael Collins orbited above. This monumental achievement not only demonstrated the capabilities of rocketry and space travel, but it also inspired generations and spurred advancements in technology and international cooperation in space ventures, similar to how Rocket Lab's Milestones are encouraging new players in the aerospace industry. 3. SpaceX Falcon 9 first reusable rocket launch 2015. SpaceX successfully launched and landed its Falcon 9 rocket on December 21, 2015. Marking a significant milestone in the quest for reusable rocket technology. This achievement demonstrated the feasibility of reusing rocket components to reduce costs and increase launch frequency, a goal that Rocket Lab is also pursuing with its Electron rocket and the development of the Neutron rocket. The success of SpaceX has pushed the entire aerospace industry toward innovations in sustainability and cost-effectiveness, mirroring Rocket Lab's trajectory in the small satellite launch market. Future outlook, predictions for Rocket Lab and its impact on future space ventures. Rocket Lab has established itself as a formidable player in the aerospace industry, particularly in the small satellite launch sector. With its trajectory marked by significant milestones between 2013 and 2023, the company is well positioned to shape the future of space ventures. Looking ahead, several key predictions can be outlined regarding Rocket Lab's future and its broader implications for the space industry. 1. Expansion of launch capacity with Neutron. By 2025, Rocket Lab is expected to launch its Neutron rocket, which will enhance the company's capabilities significantly. Designed for medium-lift payloads, Neutron aims to compete directly with larger players like SpaceX. The introduction of this rocket will likely allow Rocket Lab to capture a more substantial share of the commercial launch market, particularly as demand for larger satellite constellations increases. This competitive edge may attract new customers, including those in the telecommunications and defense sectors. 2. Increased emphasis on reusability. Rocket Lab's commitment to reusability, exemplified by its successful helicopter recovery of Electron rocket boosters, is likely to continue evolving. With Neutron designed for reusability, the company will further reduce launch costs and turnaround times, leading to more frequent launches. This trend towards sustainable practices in spaceflight will not only improve Rocket Lab's profitability but also set a standard for other companies looking to follow suit, fostering a more environmentally conscious space industry. 3. Government and defense contracts. With the recent $515 million contract from the U.S. Space Force, Rocket Lab is poised to solidify its role as a key partner in national defense and security initiatives. Future contracts related to satellite deployments, missile defense systems, and space-based surveillance are expected to expand, providing a stable revenue stream. As geopolitical tensions rise and nations focus on strengthening their space capabilities.
Rocket Lab's reputation as a reliable provider will be instrumental in securing further government contracts. 4. Interplanetary exploration ventures. Rocket Lab's ambitious plans to explore Venus with its Venus Lifefinder mission set for 2025 signify a shift towards interplanetary exploration. This undertaking will not only showcase Rocket Lab's technological advancements but may also pave the way for future missions to Mars and beyond. Success in these exploratory missions could position Rocket Lab as a leader in the commercial space exploration sector, attracting partnerships with both governmental space agencies and private companies. 5. Collaboration and partnerships. Rocket Lab's history of collaboration with NASA and other entities will likely continue to flourish. As space missions become more complex, partnerships will be crucial for sharing technological expertise and resources. Expect to see Rocket Lab engage in more joint ventures, particularly in areas like lunar exploration, satellite technology, and advanced propulsion systems. These collaborations will enhance its innovation capabilities and help distribute the financial risks associated with the high-cost space venture landscape. 6. Diversification into space infrastructure. As Rocket Lab expands its manufacturing capabilities, it may diversify into producing components essential for space infrastructure such as satellite systems, propulsion technologies, and ground support systems. This vertical integration will not only increase operational efficiencies but also create new revenue streams, reducing dependence on launch services alone. Such a move could position Rocket Lab as a comprehensive space solutions provider catering to a broader range of customer needs. 7. Global satellite constellation projects. With the growing demand for global connectivity and data services, Rocket Lab is likely to play a pivotal role in deploying satellite constellations. The company's ability to launch multiple payloads efficiently will attract clients looking to establish low Earth orbit LEO constellations for broadband internet and Earth observation. This trend will drive demand for Rocket Lab's services and may lead to strategic partnerships with major tech companies seeking to enhance their satellite capabilities. 8. Technological innovation in launch systems. Continued investment in research and development will be vital for Rocket Lab to maintain its competitive edge. Innovations in propulsion systems, materials science, and manufacturing processes will enable the company to produce more efficient and cost-effective launch vehicles. The emphasis on cutting-edge technology will not only improve launch reliability and performance but also inspire confidence among potential customers. 9. Market democratization and new entrants. As Rocket Lab continues to lower costs and simplify access to space, it will contribute to the democratization of the space industry. This trend will encourage new entrants, including startups and smaller nations, to pursue space ventures. The emergence of a broader ecosystem of players will spur innovation, collaboration, and competition, ultimately benefiting the industry as a whole. 10. Impact on space policy and regulation. As Rocket Lab and other private companies expand their capabilities, they will influence space policy and regulation. The increasing involvement of private enterprises in national defense exploration and satellite deployment will necessitate new frameworks governing space activities. Rocket Lab's proactive engagement with policymakers will be essential for shaping regulations that foster growth while ensuring the responsible use of space. In conclusion, Rocket Lab's journey from 2013 to 2023 has laid a strong foundation for its future endeavors. The company is poised to lead in small satellite launches, interplanetary exploration, and advancements in reusable technology. As Rocket Lab continues to innovate and expand its reach, its impact on the future of space ventures will be profound, influencing everything from commercial space travel to global satellite infrastructure. The next decade will be pivotal as Rocket Lab further integrates into the fabric of the evolving aerospace landscape.